So here we're going to look at writing code to see if one node is reachable from another node. Here I have graph 1. You can see in the inside set of parentheses that I have map, make edge, and then I have 3 lists. So map's going to call the function make edge with the arguments a, b, 1, and then with b, c, 1, and then with c, d, 1, and then with d, e, 1, and then with e, c, 1. And it'll turn that into a list. Next it'll call folder, and it'll keep calling add edge with the base case and then another edge that's returned from this map. So it'll call add edge on make empty graph M1 edge, then it'll take the result and call add edge of that and one more edge, so that eventually we'll get the full graph. Let's draw a picture of what that looks like. A goes to B with edge weight 1, B goes to C with edge weight 1, C goes to D with edge weight 1, D goes to E with edge weight 1, and lastly E goes to C with edge weight 1. Now let's look at some test cases for reachable. Okay, so for my first test, it asks if A is reachable from A. It's the same node, so that works. This next one's a little funny. It asks if Z is reachable from Z. You'll notice I don't have a node Z in the graph, but my definition of reachable is that it's not going to worry about that. Z does go to Z, and it's not even going to worry about the fact that graph 1 doesn't have a node Z. Next, A goes to B. Well, that's true. We have an edge there. A goes to E. That's true. It can follow along this whole path from A to E. E goes to D. That's true because I can go from E to C to D. E goes to A. That's not true. So this one's false. And Z goes to A. That's not true. We don't even have a node Z. Okay, so I've got some test cases to test a few things in this graph. Now let's look at writing the code. Before we start coding, I'll review the algorithm we're going to use. So here we're asking if we can get from node A to node B, so if B is reachable from A. What we'll do is we'll pick one edge, so that'll be the edge x to y. And I know I can get from x to y because I have an edge from x to y. And now I can recursively ask the question, can I get from A to x, and can I get from y to b? And if I can get from A to x and from y to b, then I can get from A to b. And this is going to be an example of use it or lose it, because actually edge x to y might not be necessary, so also try without it. Let's look at the code. So I already have my test written, so now I'm going to write the code for reachable. I have a bunch of different cases, so I'm going to use a cond. The first thing I want to check is if the nodes A and B that are passed as arguments are actually the same. If those are, then it is possible to reach from A to B. Okay, that's a good base case. Another good base case is if I find that the graph G is empty, if there's no more edges. And in that case, I'm going to return false. There's no way to get from A to B. We know that a graph is represented as a list of edges. And so we might think of just checking, is the graph G null? If it is, then we would return false. But when we're solving problems like this, it's important to use the interface. 1, it can make your code easier to understand, and 2, it can make it easier to change your code later on. You might want to change the representation of a graph to be something other than a list of edges. So instead of checking if the graph is null, we're going to check if the graph is empty. We can look at that definition. Empty graph. It just checks if it's null. Okay, let's go back and finish reachable. So here are 2 good base cases, and now I want to create some variables so that I can reason about my use it or lose it. So here, if neither of those were true, I'll say else, and I'm going to create a let star, which will help me create some variables to use. To be able to solve this problem, I need to work with a list of edges. So I'll say edges, and I'll call to get those edge list on the graph G. So that gets me all of the edges in the graph G. I also need to pull one single edge out. So I'll call that my it edge. In the previous example, we said that it edge went from x to y. So I'll define x and y here. X is just the source of the edge it. And y is the destination. Now my use it case. This will be true if I can get from node A to X and from node Y to B. So I can say that both of those have to be true. So that's my use it case, so that I assume the edge X to Y is in the path. Oops, did you notice I have a typo in here? Reachable takes 3 arguments, and I've only given my reachable here 2. What graph do I want to pass when I check if I can get from edge A to X? I want every edge except for that it edge. So I need to create a subgraph with that edge removed. I'll call it sub G for subgraph, and I'll use the interface method removeEdge. I'll remove edge it from my graph G, and that'll give me the subgraph with everything but that edge. Now I can fix the line with reachable, because both of these also use the subgraph sub G. So I have my use it where I use the edge X to Y. Now I'll identify my lose it where I don't use the edge X to Y. I still am going to go from A to B. I haven't made any progress, but now instead of using the whole graph, I'm just going to use the subgraph. And that subgraph doesn't have edge X to Y in it. So I figured out my use it, which is if I can get there using that edge X to Y, and I figured out my lose it if I can get there without using the edge X to Y. So the answer that I want to return, provided that A and B weren't equal and that it wasn't an empty graph, is just the and of use it and lose it. I can run the test cases. Pause the video and see if you can figure out what went wrong. Here, my code's assuming that to reach from A to B, I have to be able to reach it using both use it and lose it. But actually, I only need to be able to reach it using either use it or lose it. It might be true that I can reach it using both, but here my and should really be an or. Let's rerun. Looks good. A lot of people find it confusing when a function just returns a boolean. So here I'm taking the or of use it, which is either £t or £f, and lose it, which is either £t or £f. I'll rewrite it in a way that might seem more intuitive to you, but it's good to get comfortable with this way too. So let's look. Here I can say if either use it equals true or lose it equals true, then I'm going to return true or I'm going to return false. So this is just another way to write the code. And because this if just returns either £t or £f, I can just return the result of the or directly. Hopefully if the first version looked a little confusing, this makes it a little clearer for you. Good luck!